go into Canvas, and you will see here, final exam module is what I've called it, and it basically contains everything that you need or will be able to use. So I'll click on this one first and edit it, not edit it, oops, apologize, wrong thing. Going in student view, I have to do it that way or else you'll see it from my perspective. Right, up that and make it bigger. So anything that you need will be in that module called final exam module. Our final exam double check is Wednesday the 16th, and it's going to be from 12 o'clock till 3, right? So it starts right now and it goes all the way into the afternoon, 3 o'clock. This is going to be the structure of it, very similar to the midterm. There are going to be 10 multiple choice questions, 5 points each, that's 50 points. And I don't want to see any working for the multiple choice. All I will see is 1 is A, 2 is C, 3 is D, right? Then it's going to have a section 2. Again, it's on a PDF that you'll get in Canvas. And it's going to have 10 questions, and they're worth, on average, 25 points. That gives you a total of 250. So if you add that together, your final is worth 300 points, and that's 30% of your grade. So it's a biggie, right? 30% of your grade is going to be based on this. If you do really well in the final, you can improve your grade by quite a bit. Right? And if you do really badly, you can do the opposite of that. So you want to be as prepared as you possibly can. Now, in section 2, I need to see working, as much working as is physically possible. Sometimes that's not possible. Do you know, sometimes you do an optimization question and you can't find X because the formula is too ugly. So you just went to Desmos and you found out it was 2.12, that kind of thing. That's fine. All you do is you say, use Desmos, X is 2.12, right? But if it's doable, you should show me working, show me the algebra and so on for every question. And it's very important that you do that, because if I give you a question and you just miraculously tell me what the answer is, I'm going to give you 0 points, because all that means is that you looked up something online, you got an Ask a Buddy on a phone, and you got the answer. If I don't see working, as far as I'm concerned, you didn't do the question. So you shouldn't be able to go from a question to the answer anyway, right? There should be working between the 2 stages. And if you said I did it in my head, whatever is in your head, write it down for me. That's called working. And so you can still show me working. Here is the exam, it's cumulative. Remember the tangent stuff at the beginning, and remember the antiderivative at the end. So the first questions you're going to get are going to be from, say, limits and functions, week 1, and the last thing you're going to get is antiderivatives or optimization, week 10. So you can tell from the position in the test where it roughly came from, right? So if a question is question 2, don't use stuff from week 9, right? That's not how you're meant to solve it, right? So you're thinking about how you tackle it, do it that way.
I have a quick question.
Yes.
There's section 4.6. Can you tell us a little bit more about 4.6? I'm not sure we.
4.6 is something that you've been doing without actually knowing you're doing it. Do you know that when you put a function into Desmos to look at it, to see that its maximum and minimum is in the right place, or to check that you've done it correct? That's that guy. The one that you're going to do the working for is 4.5, you know, where it's increasing, where it's decreasing, local max and min. But you might use Desmos, essentially, in 4.6 to check it. Now, if I gave you a question that was 4.6, it would be a multiple choice question. It would be, here is a function, here are 4 graphs, which one is it? And so you would just go to Desmos, draw the picture and pick C. So you don't expect really much to go from that. 4-6 is really what you would do as a check that you did 4-5 correctly. So 4-5 would be, you know, derivatives, critical numbers, tables of signs, increasing, decreasing, all that good stuff. And then you might go to Desmos and say, yep, my picture matches exactly what it should according to what I did, right? It's got a local max where it should be. It's got a local min where it should be. You know, it's going uphill, downhill, all that kind of thing. But in itself, nothing that you're going to see a question for, unless it's a multiple choice. There'd only be one. Right, as I go through, if any questions come to you, do what Rachel just did, you know, stop me and say blah, blah, and I will try and help. Right, so what we have here is the Zoom meeting. You're not using your class one, we're using this one, right? And this one's designed to fit our schedule. Now, once this is finished, you then have, because that's 3 hours you've got to do your final. You have an extra 30 minutes on top of that to take your working, pictures of it using whatever you want. Microsoft Lens is the one I've got, but you can use any software that you've used before and upload it into Canvas so I can see your working. Now, once you've done that, you still have to check with me. I know in the rush, oh, thank goodness that final's over. I'm away to have a party, right? Hold off. Say, I've done it. I'll go and check. 9 times out of 10, it goes really quickly. Yep, it's all here. I'm good to go. Bye-bye. But sometimes I'll scan through it and I'll say, I can't find question 6. And you might say, yeah, I couldn't do that one. And that's fine. Or, oops, I have done it, but obviously I skipped it when I was doing my pictures. And so you go back and you have to do them all again and upload it. And that's me saved you a big chunk of question, right? You don't want to lose 25 points because you did a question but forgot you took a picture of it, right? So I have to check, right? I'm your backup. Second thing that sometimes goes on, but less likely, you upload it and I can't read it. It's so faint, I can't see it. And when that happens, go to another room or turn on a light or switch off a light and do it again. And if I can read it, then you're good to go. Everybody here should know how to do pictures of their stuff, right? It's use your phone and software, and I'll talk a little bit about that later. Now, your final exam has to be an honest reflection of what you can do, not what someone else can do or what software can tell you. So here's a list of what you can use, and then we'll talk about what you shouldn't use. You're allowed to use your TI-84 calculator or any other kind of calculator you've got, right? You'll use it for multiplying, for finding square roots. And you might even use it rather than Desmos as a quick sketch to see if everything looks good. Anything that's written. So you've got notes. So you're going to go through from week 1 to week 10 and check notes that you've got, maybe organize them a bit better so they're easy to find. I'm a great believer in, do you know those cards that you get? I call them cheat cards. You get a card and you write down product rule and maybe an example of you using it, and then product rule as a heading so it's easy to find. Do one for quotient rule, one for the chain rule, one for logarithmic differentiation, one for implicit differentiation, and so on and so forth, right? Or you might do a little card that is how to do. So you might have a little card and it's how to do optimization questions. And you might put an example there to remind you of the process, the steps that you would take. You might do one for how to find local max and min, right? Whatever it might be. So either do it as physical paper, which will look true for most of you. And for some of you, you do your work on like an Apple pad and you write it down, right? It's electronic, but it gets saved as a PDF. That technically, as far as I'm concerned, is a piece of paper, right? So you're allowed to use those. So if you've done your notes as PDFs rather than as physical notes, they're good. You can do it. You should have a list of all the formulas that you use. And sometimes you forget things that you might not realize you need. You need a unit circle, because couldn't you be asked to find the value of the sine of pi upon 4? Right? Well, let's throw that one out there. What is the sine of pi upon 4?
One over the square root of 2.
Okay, which is correct. I call it root 2 over 2, but Alison, you're fine. That's like totally okay answer. But if some of you are thinking, oh, I don't know what the sine of pi upon 4 is, wouldn't that be a good reason for why you need a unit circle or some way of referring back to that? So, also, don't you need to have a list of things that are what I would call derivatives that you've memorized? What's the derivative of 2 to the power of x, for instance?
Is it 2 to the power of x times ln of x, or 2?
You got it. Yeah. And again, if some of you were saying, oh, I can't remember that one, you know, that's something you need to be aware of. Okay. Last thing you can use, anything that's in Canvas. But Canvas is going to look very sparse on the day of the final. All the videos will be gone. You won't see them. WebAssign won't have any homework or any tests. You won't be able to see that on the day of the final. All that you'll get access in WebAssign will be your ebook, which isn't much help. So make sure that you've got good notes and organized in a way that's easy to get to. If your notes are, well, I've got a notebook with 150 pages in it, I'll use that. You know that you're not going to be able to finish your exam if you have to scan through 150 pages to find what you're looking for every single time you come up with a question or every second question, right? Time's going to kill you. So you may want to go and look at what you think are your notes and think of a better way of organizing them to make life easy. Now let's look at what you can't use. You can't use a calculator that has a thing called algebraic manipulation. There are calculators out there that will differentiate functions for you. You type in the function and it tells you the derivative. It's a no-no, right? Can't use them. If you don't know what an algebraic manipulation is, then you're safe. It either means you don't have one, or you never knew your calculator could do it, so you don't know how to do it in the first place, right? So you're safe either way, right? So as long as you don't do it. I can still tell if you've got one and you're cheating, because won't you just have question equals answer? Because these calculators don't tell you the working in between. For instance, if you were asked to do the square root of x, and you ended up telling me that the answer was 1 over 2 times the square root of x, which it is, I would know you were cheating, or I would assume that you're cheating, because don't you have to turn it into x to the power of half to differentiate? And then don't you have to turn that answer style points back into your square root? Do you see, I can tell, right? So don't do it, because if I don't see working, I give you 0. That's the only fair way to do this. You can't use anything online. That's a quick way of saying number 2, but let's go into details. You can't go to tutoring sites and ask them, hey, how do you do this question? You can't go to help pages, right? You can't go to software that solves it for you. That's online computer software of any kind, except things like Desmos, which I give you, right? So if it ain't in Canvas, you can't use it. You cannot communicate with any human being, living or dead. So no Ouija boards. You can't phone a friend. You can't email a friend. You can't email a stranger. You can't talk to somebody next door, etc., etc. I can't think of other ways to do it, but even if you can, don't, right? It's what's in your brain and what's in front of you is paper, right? That's basically what you're allowed. And that is it. Are there any questions about the final that I haven't covered there? Are we good so far? Right, so let's nip back and just do a little bit more on what is in Canvas. To show you what you get in Canvas then, this guy here is the link to this Zoom page, right? So you want to go to Zoom, this is where you do it. You have to have your camera on. I need to see you for obvious reasons. When you click on that, it's empty right now, but the final will be here as a PDF. There's Desmos, whenever you want to use it. In case you haven't used it for a while, here is the link. If you've got an Apple, use this link. If you've got Android, I say this one, and Apple, use this one. And here's a video to show you, to remind you how to use it. Let's say you've done the final, you've got it up, you've got it as a PDF. Just remind you what you do next. Click on upload. This is where you will send it so I can read while you're working or see it. Hit start assignment, upload file, choose a file. Let's say it's that one, open, and finally submit. That's it. That's how I get it. Right. Now, if you find that you've missed a question or you want to do it, new attempt, upload final, add another file, whatever, boom, right, and I can get it that way. That's about everything I want to say about in general of the final. Is there any questions before we move on to specifics?
How early can we print it out when we work on the paperwork?
Are you talking about the final? You actually physically want to print it? Is that what you're doing?
Right, that's what I did with the midterm. Is
You don't
printed it
need
out.
to print it. You know, you can simply just write it, the answers down. I know what the questions are, so I don't need to see them. I mean, that might save you some time as well, because printing can take forever. You know, you can just look at the screen, read question 1, do the answer, read question 2, do the answer. You can do it that way. Any other questions? Okay, let's move on to specifics then. It's up to you. What topic? Have you got a question that you'd like me to do, or you would like me to go over some particular topic? I'm willing to hear. You tell me and I'll do it.
Can we see the list of like the
topics?
Yeah, the topics.
Okay, give me a second. I'll see if I can find that relatively quickly. Give me a few seconds. I've got the wrong window open. Now I have to find the right window and then make it bigger. Almost done. Okay, I'll switch over and you can have a look.
While you're doing that, can you tell us what the schedule is for class next week?
Yes, Monday is a review for final day, just like today, but it's an open-ended one. So if you don't turn up on Monday, I'm going to assume that you're studying for your final and I will give you the attendance for Monday. If you turn up on Monday, you might only turn up to find out how to do one thing and then leave. You might turn up on Monday and just watch everybody else's questions because that's a good way for you to learn, and that's it. So it's a very flexible Monday. You can turn up or not. You can turn up for the last 10 minutes, the first 20, whatever you want to do, ask a question and leave. Very open-ended. Right, are you all now looking, I hope, at the list? Is that what you see, Vanessa? Right. Does any of that pique your interest and you'd like to see an example of it?
Can we do a example of a limit, like a more complicated limit?
Okay. Let me think of what I could do here. Are you talking about a limit as x tends to a number, or a limit as x tends to infinity, or you get any kind of ideas of what you're looking for?
Either or.
Okay, so let's do a limit as x tends to 2 of e to the x. Oh, let's make it 0. That's good. E to the x minus 1 over x squared. Right. Now, in this particular limit, I'm going to be using what's called L'Hopital's rule. Right. I'm going to do an example of different techniques, different situations. Now, if you plug in 0 here, you get e to the 0 take away 1 on the bottom, and you get 0 squared on that. E to the 0 is 1, and 1 take away 1 is 0, and 0 squared is 0. That we call indeterminate form. So when you do L'Hopital, you can only do it when things that look like this, right? 0 over 0, or less likely infinity over infinity. According to L'Hopital, then, what you do is you find the derivative of the top guy, which is e to the x and nothing, and the derivative of the bottom guy, which is 2x. Now, if you put in 0 now, you get e to the 0, 2 times 0. You get 1 over 0. And 1 over 0, as weird as it looks, is actually going to get you the answer. 1 over 0 is equal to something. What is 1 over 0 equal to? And I called it something for a reason. Infinity, yeah. It's okay for the answer to be infinity, right? In fact, that's a valid answer. Technically speaking, I would have put a little plus there, but that really doesn't do anything. It's still infinite. So that would be an example of using L'Hopital. Now, when you do L'Hopital, if you do a really difficult one, don't you do the derivative, you plug in the number, and it's still no good. So don't you just do L'Hopital again, you plug in the number, oh God, it's still no good. You do it one more time, you plug in the number, and it's 2/3. So L'Hopital can be done repeatedly until you get an answer. And an answer will be infinity, 2/3, or 0, right? That's the typical answers you get, right? You get 0, you get an infinity, or you get some fraction or number. Second kind is a guy like that. Now, I could do this guy with L'Hopital, but I've chosen to do this one using a method called factor and cancel. Can anybody see a common factor that you could pull out of the top expression?
X squared.
Okay. And you get that. And the whole trick in factor and cancel is, shouldn't the factors cancel, right? If you've done it right. Then what we're looking at then is simply just the limit as x tends to 3 of x squared, which is 3 squared, which is 9. So there's your answer. And then you get a guy that looks like this.
Oh, conjugate.
Oh, you've already figured it out. Yes, conjugate. If you get a limit with a square root, could be in the top, could be in the bottom, don't matter. If you see this guy, doesn't that mean the conjugate method? Now, this guy here in the middle, do you know I could have done L'Hopital and it would have worked? Because L'Hopital works really well with fractions where they're just powers, right? L'Hopital would work. If you try to do L'Hopital in this, can you just trust me that the thing is so darn ugly you won't want to do it again, right? The square roots do not play well when you differentiate them. Don't they just get weirder, right? And L'Hopital doesn't like getting weirder. So the conjugate method is essentially you multiply the top and bottom by a special version of 1 called the conjugate. And it's made up of the same two guys, but with a plus instead of a minus. So far, so good. And let's see what that looks like then. Typically, you shouldn't do anything to the bottom. Just write the horrible mess down exactly the way it looks. Now, if you multiply this ugly fraction by that ugly fraction, right? So if you multiply this by that, you will get eventually, when you do FOIL, you end up with 2x plus 2 take away 6. Can you trust me on that? If you've done enough, you'll know that's what you get. Now that simplifies a little bit. And so we now have 2x take away 4 over x minus 2 over the square root of this guy plus the square root of 6. Now, one of the things that should happen with the conjugate method is that there should be a cancel. And sometimes it's an obvious cancel, and sometimes you have to do a little bit of work. Do you notice that the top can be factored? Can't you pull out a 2? So if you did that, you now have 2 lots of x minus 2 all over this ugly stuff. And now you can get the cancelling, right? And so what do I have? Well, if I plug in x equals 2, the top is 2. That guy there is 2 lots of 2 add 2, which is square root of 6. That guy is also square root of 6. Now, style points. A square root of 6 plus another square root of 6 means you've now got 2 square root of 6s. The 2's can cancel, and you have got 1 over the square root of 6. Or you can, simplify by multiplying by root 6 over root 6 and get the answer in a slightly different form. If you did that, it would look like that. Both are correct. And I'm pretty generous in the final. If you write that, I'm giving you. If you write this, I'm giving you. In fact, if you write that, but make a mistake doing that, I'll still give you the points because I'll stop looking there. When you're doing a test, working is important, not just to prove to me that you're really doing the question, but it's just as important for you to get points. If anywhere through this process, a 2 turned into a 4 or a plus turned into a minus, right? Because that happens, right? In the stress of the test, you do mistakes. You will still get points, partial credit, because what I do is I look at the method. Yep, she used the conjugate. Yep, she multiplied it. She combined it. She tried to do this, but she screwed up a little bit. Maybe that's a 4 and not a 2. Maybe that's an add, whatever it is. But if you do 90% of it right, and the only thing was a plus was a minus or a 2 turned into a 4, right? Things like that. 90% correct, you still get 90% of the points. But I can only do that because I can see you're working and I know you did it right. If you just tell me the wrong answer, you're not getting any points anyway, but you can see I can't give you partial credit if all you tell me is the wrong answer and I have no indication of how the heck you got it. So working is important for you to get points as well, right? So err on the side of safety and tell me more things, more lines of working than you might have done in a typical homework question. Because don't you do, well, I can jump from there to there, right? I can do that in my head, right? Or I can jump from here to here or whatever. In a homework situation, that makes sense, right? Because you have tons of questions you want to be finished sometime today. But in a final, be a bit more generous, right? Try and show me every sensible piece of work, right? Even if it's relatively simple, just in case, not that I've ever done it, but if you do something in your head, don't you sometimes do it wrong? At least if I see the lines, you're less likely to get it wrong. And still, even if you did get it wrong, won't I know that you were doing it right? Yeah. Did that help, Vanessa, or was there some other limits that you were wanting to see that I haven't done?
No, that helped. It just was in the beginning, so I was kind of rusty, but that helped a lot. Thank you.
Okay. Right, we're doing our thing, guys. What's next?
I'd
Do you
like-
want it?
I'd like you to go over continuity,
Okay.
especially
Continuity.
the kind of answers you will accept from like the absolute min and absolute max.
Continuity. Oh, and
Yeah.
absolute max and min. I got
Yeah,
you.
like the ones with the open holes,
Right.
They're the end points and all that.
I gotcha. Right. So most continuity questions will begin life as a graph, right? That's the usual way that you ask people about it. So I'm just going to create my own little graph here. Let's say x equals -1. I'll do an open dot to kind of add your idea. I'll do a guy that looks like this, or maybe I'll do a V here. I'll do a solid dot here, and I'll do a piecewise, right? And I'll finish with a solid dot, right? So I've got as many little things going on here as I can think of. This guy here is going to be 3. This guy here is going to be 7. This guy here is going to be 11. And this guy over here is going to be 15, right? So I'm giving you the x coordinates of all the key numbers, right? So continuity is basically for what values of x is the function nice and smooth. So the way I tend to look at it is a kind of analogy. I'm going to start here and drive my little car. And if I get killed, it's discontinuous. So would you agree at 11, I would fall off a cliff and die? So if you were saying where is the function not continuous? That's how I would probably phrase that. Would you agree it's not continuous at x equals 11? Does that make sense? Now, if you want to tell me when it is continuous, you would have to tell me a whole interval of values. So I would start at -1 and I'd finish at 11. And then I'd start at 11 and I'd finish at 15. And these are not coordinates. These are x from -1 to x equals 11. Would you agree from there to there, the function is one continuous road, I don't get killed? And isn't there a problem at 11? So a little curve bracket. And then at this side. Now, open dots and square dots. When you're talking about continuity, if there's a solid dot at the end, you can count you can count that point as part of continuity. If it's an open circle at -1, you see that's curved and that's square. Okay, that makes sense. Continuity, tell me where it's not working or tell me where it is. Depends how the question's phrased.
Professor, at 11, wouldn't there be a closed bracket also?
Well cut, yes.
Okay.
Now, max and mins and local max and mins, there is a little bit of different ways of looking at it. So I'll tell you what I'm interested in. But what's that something? If you answer these questions according to the other way of looking at it, you will still be correct. So I'm going to allow both versions of the correct answer. So what am I getting at? In this shape here, I guess I could have done this a little bit better. Can you pretend that's at the same height? Can we pretend that that value there, both of them, although it doesn't matter for only one of them, are at a height of 11, right? This shape has an absolute maximum of 11. That just means the biggest y value. Now, let's look at this guy. Would you agree this guy down here? Let's pretend it's -5. Would you agree that is the lowest point that this graph gets to? You agree it doesn't get any lower than here, right? Everywhere else is a little bit further up than that. That guy The answer is none. There is no absolute minimum. Why? A little open circle. If there's a circle there, a little open circle, you can't use me. Now, most people agree on this. Don't think there's much disagreement. There's a big disagreement about local max and mins. And not just me, a lot of people, local maxes have to be hills and local mins have to be valleys, right? As the convention that I would use. So in this shape here, wouldn't this point here be a local maximum? Would you agree? And wouldn't this point here be a local minimum? So I could tell you that there's a local maximum at, say, x equals 3, and there's a local minimum at x equals 7. And as far as I'm concerned, that is it, right? However, as you have experienced in WebAssign and other people, not just WebAssign, there is another school of thought that says local max and mins don't need to be hills or valleys. They just need to be a place where the function is higher than anybody around me. So if you look at this weird fella, would you agree that at that point there, it's higher than anybody else around? In WebAssign, they would call that a local max. I wouldn't, but they would. But if in the final exam you want to call that a local max, I will give you the points for it. So you don't need to worry about which school of thought. Whichever school of thought you've decided to join is fine, right? I think life is easy if it's a hill and a valley, and I'm not the only person who thinks that, right? Local max, a hill, right? Is it possible for a shape to be absolute max and a local max? Yeah, and it's possible to be a local min and an absolute min, right? Those are allowed. Now, since I've got this picture in front of me, isn't x equals 11 a discontinuity? What name do we give to that particular shape?
Jump discontinuity.
Right. That would be a really good multiple choice question, wouldn't it? What is happening at x equals 11? I could just say a jump discontinuity, a vertical discontinuity. I could just call it a discontinuity, or I could say it's continuous at 11, right? There's not a problem, right? Amongst others. So in a multiple choice, knowing the names of things is a good place for me to put that type of question. Right. Is there any other place in this that is discontinuous? I can't see one. If you can see one, tell me. Would you agree the shape's okay except at 11, right? You can travel along it and not die. Which is basically what that's saying. What else could I do? If I had this shape, what would the derivative be at x equals 5? What would the derivative be at x equals 5?
0.
It would, wouldn't it? Would you agree they're horizontal? Not so obvious. What would the derivative be at that little cusp thing, right? The little triangle-y thing.
That undefined.
It would be. Wouldn't on this side it be +5 and that side it would be -5, right? It would cross over weird. In fact, isn't that where critical numbers live? Zeros and undefined. So if you want to visually think, why do we look for them? We look for zeros because hills happen, and we look for undefined because little V shapes happen, amongst other things, right? Good question. Who's next? Oh God, look at the time. Right, we still get time, but it's rushing away from us. Right, while you're thinking, I'll switch over to the screen with the topics.
Do you think you could do like an implicit differentiation one really quick?
I can. Okay, I didn't need to do that. You got an idea right off the bat. It's a very localized technique called implicit differentiation. This video will be online, just like Mondays will be. Okay, let's suppose we wanted to do x cubed y squared plus 2xy plus e to the y equals 10, right? And you're being asked to find the derivative of this implicit equation, right? That's the question, right? Find dy by dx. So take this guy and you differentiate him. Now, he's made up of two pieces. So this is going to be f and this is going to be g, and I'm going to do the product rule. And the trick here is do exactly what you would do when you differentiate x's. Do exactly the same rules. But when it's a y, remember to finish with the dy by dx. Okay, so here goes. Differentiate this guy, you get 3x squared, leave the other guy alone, plus leave that guy alone. Now, if you differentiate y squared, you get 2y, right? It's the same rule, right? Y squared, 2y. But remember to finish with a dy by dx. Are you comfortable about that? Product rule. Would you agree this is also a product rule? So it's going to be f dash g plus f of g dashed. Let's see what we get here. Differentiate 2x, you get 2, leave the other one alone, plus leave the first guy alone. And what do you get if you just differentiate a y?
dy over dx.
And I like what you said. I'm just going to rewrite it as 1 times dy by dx, just to emphasize that you did differentiate a y and got a 1. Now, e to the y, well, if you differentiate e to the y, you do get e to the y. What else do you get? If you differentiate e to the y, you get e to the y times
dy dx.
every single time. And don't get caught out by this. If you differentiate a number, don't you just get 0? Now, from this point onwards, calculus is finished. It's all about algebra. And we are going to find what dy by dx is. So the first thing I'm going to do is leave all the terms that have a dy by dx in them, and I'm going to leave them on the left-hand side. So it ends up being these 3 pieces. And then I'm going to get rid of that guy because he doesn't have a dy by dx by subtracting them from both sides. And I'm going to get rid of that guy for the same reason. I'm not going to do anything now to the right-hand side. But what shall I do with these 3 terms?
Factor out dy by dx.
And if you look back, isn't that exactly the same thing you did every single time you did one of these, right? It's part of the process. Right? So I'm going to take or pull out a dy by dx as a common factor. I now have 2x cubed y plus a 2x plus an e to the y equals that guy. So what do I now do to find dy by dx? Again, this is pretty much standard every single time. This is what happens.
Divide both sides by what's in the parentheses.
Yeah, I think I tend to call it divided by the ugly guy, right, which is this. Normally, shouldn't I try and do some style points in this, right? Factor it. I could pull out a common factor of y, but there's no real benefit, so I'm not bothered. The only time it would be helpful is that if I factored this and factored that and I got a little bit cancelling, then it would be worthwhile. But if you know that's not going to happen, then pretty much that's your answer as far as still points is concerned. I don't think it's a word of warning, but you're only going to get 10 section 2 questions. And there's a lot more than 10 topics in my list. So half the things you study for will not appear in the final exam. Now, I'm not saying implicit is in the exam or is not. I'm just using this as an example, right? But half the things you're going to study for are not going to be there, right? You might not get logarithmic differentiation, right? You might not get a question involving limits or continuity or whatever we've done today, right? Half of those things, quite random, will not appear in the final. And you know what Murphy's law is? The half you don't study for is the half that appears on the final. So you have to study as if everything could be in the final, and that way there won't be any shocks. So try not to pick anything out of my brain like, oh, he seemed to be pushing this, or he seemed to be poo-pooing that he's sometimes giving me a clue that this is in and that's out, or whatever. It means nothing like that. I haven't even written most of the final yet. I don't know what I'm going to be putting in it until I get to grips with it. This weekend, you will be getting a report. Come hell or high water, you are getting a report. It will tell you everything that we have done up until basically last Sunday. So you won't get your grade for week 10 assignment or the grade 10 online. But what you will get instead is an extra piece of information. I will be telling you on that letter how many points out of 300 you need to get in the final to get a 2.0, to get a 3.0, or to get a 4.0. So it gives you a goal, right? I need to get 210 points in this final to pass that kind of goal, right? So that's set up. I've done the spreadsheet part to make that happen, but I haven't got all the data or the letter yet. But Sunday is a good day to look for it, right? You'll get it this weekend for sure, but probably on Sunday. Any questions before we go? Because it is time up now. Well, it has been fun. This is maybe my last chance to see you all as a class, because some of you might not be here on Monday. It has been fun. I have enjoyed it. I tell all my students the same thing. You're going to be evaluating me if you haven't already. There is one simple rule about that, and here goes. You can say anything you like about me. That's totally acceptable. But if you say anything about my jokes, they must be good. Only good comments about my joke. So bear that in mind, because I know where you live and I can find you. So if you say anything, that sounds like a threat. You know what, I'm joking, right? Have a nice day, everyone. I will hang about. It looks like you're, oh, hi. Bye-bye. I'll see you maybe on Monday.
Just double checking. I'm pretty sure I know the answer, but this in class and Monday is more of our review than we kind of got a PDF for the midterm that we could kind of like double check, and then it was basically like a practice run, so we won't get that this time.
Yeah, I don't have one of them, unfortunately. So the best you can do is watching these videos and looking up your past exams and your past homeworks.
Alrighty.
Okay.
Have a good weekend.
You too, Natalie. Bye-bye. Teresa or Jonathan, does either of you two have a question for me?
I have a really quick one, so
Go for it.
I'll go first. So next quarter, are you gonna be teaching Calc 2?
I have no idea. Does it say my name on Calc 2?
I took a peek and I'm not quite sure.
Hold on a second. I think I've got my schedule somewhere.
I asked you the same thing, I think a couple of weeks ago, and you looked it up and you weren't.
That shows you. So, no, Jonathan, you're going to have some other fun person to take it with instead. What did I
really enjoyed this
You've
class.
got me in here. What am I thinking teaching? Let's have a look at what I'm teaching. I'm just curious now that you've got that. I am going to be teaching Calc 1. What one's this? Oh, Calc 4, Calc 1. That's an old one. That's only half picked. What was the one? Oh, here it is. Round 3 or second overload. Darn in space. Second overload. There we go. That's the final one. And here we go. I'm doing trig, stats, Calc 1, Calc 3, Calc 4.
Oh, so it's everywhere around Calc 2. Okay.
Yeah, that's it, just the way it is. I think
Yeah.
in the summer I'm teaching a Calc 3 or a Calc 4. I think. I'm not 100% sure. Don't quote me.
Well, either way, I've really enjoyed this class. So,
Oh, thank you. That's nice of you.
well, I guess we'll see you Monday then.
See you Monday. Teresa, you have a question for me?
Yes. I'm a little bit hung up on the final question of 4.9.
Okay, let me go hunting for that question.
Because it gives you,
4.9. Let me just
yeah,
hold that thought for a second, Teresa. That way I can get your version of it. Teresa, see. Where does court come from? Do you know the ancestry?
yeah, I think we're Scottish and Irish.
Oh.
When my family came over, it was actually spelled Courth, I believe, like Courthe.
Oh.
And they gradually changed it, and it's actually pretty neat. My dad and my aunt that has since passed, they got really into our family history, so we have
Yeah, keep
a
that
whole-
stuff, because that stuff
Yeah.
disappears like nobody's business. Nobody in my family has bothered to keep track of it, I guess, because we're just not into that. I think when I retire, I'm going to spend some time doing that, because I think it's important for the next generation to know where you come from. And
It really is. I think so.
Right, so I'm on that one. So the question number is what, 25 or 24?
Yeah, 25.
25, okay. So
I messed up something on 24, but I have to go back and redo it. I think I did
Okay.
something silly.
I'm writing down your version of 25 as I speak, and then I'll put it on the screen and you can see it. If it's the one I'm thinking of, they've told you the acceleration and you have to figure out what the position function is. Is that correct?
Yeah, and I guess I don't understand how you can go from, because you have to go A of t, then solve for V of t to get to S of t.
Correct. Yeah. So you're not sure quite the mechanics of how you would do that. Okay.
Yeah.
Well, let's show you. Click on. Right. First thing I'm going to do is go from acceleration to velocity. And that's going to be finding antiderivatives. So add 1 to the power and divide by the new power.
Mhm.
Add 1 to the power and divide by the new power. The number 3 gets you 3t, and then we have an unknown constant c. So far, so good?
Mhm.
So let's continue then. To find the position function, antiderivative again. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. Now it gets a bit weird. This, when you find its antiderivative, this is a number, so its antiderivative is the same number, t, and then you need another unknown guy called d. So far, so good?
Mhm. That's
Right.
as far as I got. I didn't know what to
Okay.
do after that.
Well, let's use boundary condition number 1. So S of 0 is 0. So I know what S of 0 is. It's 1/12 nothing to 4. Take away 2/3 nothing. Plus 3/2 are nothing. Plus C times nothing, which is still nothing. Plus D. And I know that's equal to 0. And so what I've figured out is, oh, if all of this plus D equals 0, then D must be 0.
Oh.
And so I will now return back to this function and do that guy, take away that guy, plus this guy, plus this guy, plus nothing, so I won't write nothing. See, if this had been d equals 2, I would have said plus 2 here. Now I'm going to use boundary condition 2. And it says that s of 1, which is 1/12 times 1, take away 2/3 times 1 cubed, plus 3/2 times 1 squared, plus c times 1, which is c, and that should equal 20. Now, if I want to know what c is, couldn't I just, well, I could combine them and subtract it, but I'm too lazy to do that. So how about take away a 1/12 from both sides, add a 2/3 from both sides, and take away a 3/2. That way I can just get the whole thing done at one go. And so it's 20, take away 1/12, add a 2/3, take away 3/2, and math, fraction, go. 229/12, which is weird as it is actually the right answer. So we now know everything. S of t is 1/12 t to the 4, take away 2/3 t cubed, plus 3/2 t squared, plus ct, plus 229/12 c t.
So it was that simple.
Does-
Okay,
Right, does it make sense what I did? Do you follow the logic of it?
it does. I guess for some reason I thought I had to somehow find the v of t.
But well, that does happen, not in this question. Sometimes they tell you v of 1 is 7, right? I've seen questions where they tell you v of 1 is 7 and s of 1 is 20, you know, that kind of thing. Now, if they tell you v of whatever the number is 7, can't you then find the missing c now? How can I do it? Well, if you tell me something in terms of v, can't I find c? But if you only tell me things using s, you see I can't really do much until later. So that's what the difference was. The information they give you is going to decide how you're going to find the missing c and then later on the missing d. In this question, you see, because the information was here, we got a d, and then from there we got the c. But in another world, you know, I can imagine a story where these are the two boundary conditions. Wouldn't we get c using this one, and then later on we could get d using this one?
Yeah, okay.
Okay.
That makes sense. Thank you very much. That not losing my mind.
No, you're not losing your mind. Okay, are we good to go then?
Do you have like a couple more minutes?
I can do it, sure.
Oh, okay. I know we did this one in class, a different version of it, number 9.
Right. On this same session?
Yes.
Okay, let me scroll back to get your version of 9. That way we can use the same numbers. So we're being asked to find an antiderivative of a really weird fraction. Now you can't find antiderivatives of fractions, right? We don't have, remember that table, which I don't have a copy of, but you know, the one that told you the antiderivative of e to the x and sine the x and x and then that one. None of them are this guy. So what you do, it depends how you want to set it up. This is one way to set it up. Multiply by x to the -2. So an x squared on the bottom is the same as multiplying with an x to the -2 on the same level. Now, if you multiply these together, this guy times this guy gets you 2. This guy times this guy gets you -x to -1. And this guy times this guy gets you 9x to -2. And then I'm going to rewrite these guys like that. So that is the algebra version of how to take this and turn it into something that we can find antiderivatives of. Let me show you a different approach to the same question. And sometimes one way makes more sense to a person than the other. I'm going to take each piece on the top and divide it by an x squared. Now they cancel out and you get a 2. They partially cancel and you get an 8 over x. And that guy is 9x squared. But for differentiation purposes, that guy has to be called 9x to the negative 2. Do you see that you end up with the same answer, but just looking at it from a different algebra perspective?
Oh, okay.
Are both of them okay, or do you prefer one compared to the other? It's totally your preference. Do you have a choice?
I think it's the first version.
Okay, so that would be the way you should tackle it. Now, that only got us to the place where we could now find its antiderivative, right? We haven't actually done the antiderivative part yet. All we've done is write it in a form that would allow us to do the antiderivative. So here we go, antiderivative. 2 gets you 2x. What does an 8 over x get you?
The natural log x.
Right, so there's going to be 8 of them, right? Now, this guy here is written exactly the way I wanted it to be, even although it looks weird. The power rule works for negative powers. The power rule works for fractional powers. So you add 1 to the power, and then you divide by the new power, and finishing with plus c. Are you happy about adding 1, dividing by the new power?
Adding, oh,
Adding 1 to the power, and then dividing by that new power.
I think I went the wrong way.
Ah, you got a negative 3 maybe? Differentiate
Yeah.
or something. Now, style points, you should convert that guy back into a fraction. The other are fine, but that guy should be called that. Okay, practice at negative ones. If you want to find the antiderivative of that guy, you add 1 to the power, you get negative 2, not negative 4, right? If you add 1 to a negative number, it gets a little bit warmer, right? It becomes negative 2, and then you divide by the new power. If you did that guy, you'd add 1 to the power and then divide by the new power. You see how that works?
Yeah.
Right. Okay.
Okay.
What's next?
Thank you. I haven't figured out what I did wrong in 24 yet. But
Okay, let me find out what 24 is since we're here. That's good. That's good. You seem to have picked up a T from, lost a T from somewhere. So it looks to me like when you used V of 0 equals 4, the answer should have been 1, and it wasn't. So let's see if I can figure that out. So you've got A of t as 8 cosine t's, take away 3 sine t's. Let's find the antiderivative, which gives you the velocity. What do you get if you find the antiderivative of 8 cosines?
8 sine t.
Correct. And you got the sign correct, the positive. Now, what do you get if you integrate negative 3 sine t's?
I got positive 3 cosine t.
You nailed it. Plus a guy
Plus
you don't
c.
know, right?
Mm-hmm.
And now you are told a boundary condition that the velocity at 0 was 4. So the velocity at 0 is 8 times sine of 0 plus 3 times the cosine of 0 plus c, and it should equal 4. Well, sine of 0 is nothing, so that's nothing. Cosine of 0 is actually 1, so 3 times 1 gets you 3. And now you've got that guy. And if you subtract 3 from both sides, you've got 1. And so now your velocity function is 8 sine t plus 3 cosine t plus 1. So when you move to the last step, which is the position function, You differentiate that guy, which you did correctly, so you get -8 cosine t. And you integrate that, which you did correctly, and you get -3 sine t. But what will you get when you integrate +1?
Is that just a 1t?
Yeah. And then I'll call it C because I'm lazy. Could call it D if you prefer. And then we'll use the boundary condition that the position at 0 is 0. Okay. So the position at 0 is -8 cosine zeros plus 3 sine of zeros plus a 0 plus a c, and the whole thing is 0. Cosine of 0 is 1, so that's -8 plus nothing plus some more nothings plus c equals nothing. So -8 plus c is 0. And if you add 8 to both sides, there you go. And then just put an 8 there. And that's the answer that we're looking for. Because c ends up being an 8.
That's what I got.
You did. And the reason why you still got 8 was that if that term was missing, you would get 8. And if that term is 1t, but since t was 0, you didn't notice it, right? So you missed the t because you missed the +1.
Oh.
So that's the only bit you were missing. Your answer was that, and the right answer was this.